In this video, we are going to look at adding and subtracting rational expressions with like denominators. Remember rational expressions, rational really means fraction. And so these rational expressions, the arithmetic and the math really works a lot like if we were doing fractions. So if you remember back to when you first learned how to add and subtract fractions a long time ago, remember if we have something like 4/5 minus 1/5, remember to add and subtract fractions, we need a common denominator. These fractions already match, so the denominator stays 5. And we just do the arithmetic to the numerators across the top. So 4 minus 1 is 3. So in this section, everything is going to have a common denominator already, so we don't have to worry about that. That common denominator will just remain the same whether we're adding or subtracting. And then we'll just do the arithmetic across the top with the numerators. So let's jump in and look at some examples. Here's our first one. We have a common denominator of 4x. That means when we subtract, we will still have a denominator of 4x. And we do our arithmetic across the top. We have the 7 plus 2x minus 7. Simplify by combining any like terms. We do have like terms here. We have a positive 7 and a negative 7. So those combine to 0. That means we have now 2x over 4x, but we're not done. We should simplify that rational expression, canceling any common terms. So since there is an x on the top and an x on the bottom, they cancel each other because they are both factors. So now we're down to just 2 over 4, which is a fraction that can be reduced. We can divide the numerator and denominator both by 2. So our final answer here would be 1/2. Next up, number 2, again, we have common denominators, so that denominator will just stay y minus 3, and we'll do our arithmetic across the top. We have y plus 3 plus 2y minus 12. We want to look for any like terms that we can combine. We have a y and a 2y, so that gives me 3y. And then we have a plus 3 and a minus 12. So that gives me minus 9. So we've done our addition, but we're not finished. We should always simplify our result if we can. We can start by factoring that numerator. We can pull out a greatest common factor of 3. And now we can see why we want to do that. Once we factor out that 3, we get 2 common factors that can be canceled. So this simplifies to just 3 over 1, or a final answer of 3. So the adding and subtracting here is not too tricky, but we're going to get some good practice simplifying rational expressions. So we'll keep going through several of these examples. Here, this next one has a common denominator of x minus 3. So we'll do our arithmetic across the top. We get x plus a negative 3. Which could be rewritten as x minus 3 over x minus 3. What's that going to look like? Well, those common factors basically each cancel each other, but keep in mind it doesn't disappear completely. That means our final result is 1. Next up, this time our common denominator stays x squared minus x. And we add those numerators, x minus 4 plus 4. Combine any like terms. So that minus 4 and plus 4 are going to knock each other out, and we just end up with x over x squared minus x. We can factor a GCF, greatest common factor, out of the bottom. And when we do that, we can now cancel the x and the x. Now be careful, even though we canceled the x on the top, remember there is still a placeholder there, still a 1. So we have for a final answer 1 over x minus 1. That x minus 1 can't jump out of the denominator. It's got to stay in the denominator. So even if everything in the numerator cancels, there really is still a 1 up there. Okay, we're going to skip those next 2 and try a couple on the next page. How about number 7? Our common denominator this time is 5. Arithmetic across the top, we get 3a plus 2a minus 5. Combine your like terms. and that gives us 5a minus 5. Factor your GCF out of the top. And now that we have it fully factored, we can see that those two 5s cancel each other, and our final answer would just be a minus 1. How about number 8? This time our common denominator is b minus 8, so that stays across the bottom. Up top, we get b squared plus 64. We are subtracting this time, so it's a minus 16b. And what do you think we should do there? We do need to simplify. Look at the top of that rational expression. That is a quadratic expression. Maybe we'll rewrite it in order in a standard form. So we have b squared minus 16b plus 64 over b minus 8. And when we write it like that, we see that that top maybe looks like something we can factor. Let's take a look. So b squared factors into b times b. 64 has many factors. The first one that pops into my head is 8 times 8, and it looks like that's going to work out for us because a negative 8 plus a negative 8 gives me that negative 16 in the middle, and negative 8 times negative 8 also gives me the 64 I need at the end. So there's our factorization. Then comes the fun part where you get to cancel, and our final answer here would be b minus 8. Number 9, take a minute and think about this one. Right now, we do not have a common denominator, but there's one little trick we can do to make a common denominator here. It's not too complicated. So on this second fraction, if this was x minus y instead, meaning if the signs of both of those terms were changed, we would have a common denominator. So what I'm going to do is I'm going to take this fraction, and rather than having the negative on the top, because that negative can go anywhere on the fraction, I'm going to write it on the bottom. And then I'm going to distribute it. And then I'm going to rewrite those two bottom terms in a different order, the positive x and then the minus y. So that second rational expression, that second fraction is equivalent to a positive 17 over x minus y. So now if we write it out, you can see we do have a common denominator. And 17 plus 17 is 34. There is our final answer. Let's take a look at number 10. Here we have a common denominator. That's good. The common denominator is 60. And we're doing a subtraction. Now here's where we have to be careful. We have to subtract the entire numerator we see here. So when you write it, you might want to use some parentheses, or remember that you have to switch every sign. I'm going to write it with parentheses so we can see exactly what's going on. So we have to subtract that entire numerator, which means when we distribute that negative sign, notice we're going to have a minus x, but it is going to become a positive 5y when we distribute the negative. The negative has to apply to both terms there. Nope, I forgot the x in the new denominator. Okay, then we should look for like terms. We get a couple things going on. X minus x, those two go away, so we're left with just 5y plus 5y. So up top we have 10y over 60x. 10 over 60 can be reduced. Both of those coefficients can be divided by 10. So we end up with just 1y, or y, over 6x for that one. Okay, we'll do one last one. Again, when they have a common denominator, these problems aren't too tricky. You just need to remember the basic rules of fraction arithmetic. Here, keep that common denominator. Do the arithmetic across the top. Being careful, make sure you subtract that entire numerator of that second fraction. So up top, I'm going to distribute that negative sign. So it becomes minus 2x and minus 7. I'm going to go ahead here too and factor that denominator. I just bet I'm going to need to factor it before we're done. This one has kind of big numbers, so we'll make our little table over here. And 78 times 2 is 156. And we're looking, oh, it's negative, sorry, negative 156, and we're looking for a sum of negative 1. And I'm actually using my calculator to find those factors because those are pretty big numbers. And let's see, we're looking for two numbers, and I see them right here, a 12 and a 3, a 12 and a 13. If we want a negative 1, we want one plus 12 and minus 13. So I'm just going to write it down here. 2x squared plus 12x minus 13x minus 78. Factor by grouping. Negative 78 divided by negative 13 is positive 6. So I can see here the x plus 6 is one of my factors. And what's left behind is 2x minus 13. That's my other factor. Let me write that a little neater. So I kind of took a little time out there and factored the denominator. Now I'm just going to continue. Now I need to look for like terms up top. I have 3x minus 2x, so that's just an x, and 13 minus 7, which is plus 6. Oh, look how convenient that is. So when all is said and done, again, we get these common factors. Remember, if you cancel everything up top, you still have a 1 up there. So our final answer, 1 over 2x minus 13. And that's it for this video.